Question 10. Given JM is the diameter of the circle, PN is parallel to KM, GL is a tangent to the circle, JK is equal to 20 units, and KM is equal to 7 units. Okay, so when you're reading these questions again, you look for keywords. So diameter is the first keyword I have here. If I have a diameter, I know that there is a theorem that says that the diameter subtends an angle of 90 degrees at the circumference. So if JM is my diameter, I can use that fact to show that angle K is equal to 90 degrees. Also that angle H, if I need it, is also equal to 90 degrees. That's because the diameter subtends 90 degrees at the circumference, or it's also called angle in a semicircle. Okay, then I go on and I see that PN is parallel to KM. The word parallel, again, I need to think of alternate angles, co-interior angles, and corresponding angles. So if I look here, I will be able to see corresponding angles. K there will be equal to angle, the top of angle P, which would be angle JPN. Those would be corresponding angles, so that JPN will also be 90 degrees there. Let's see, GL is a tangent to the circle, so when I see tangent, I like to look for tan chord theorem, but there's no angles given here. So I can also take note that the diameter is perpendicular to the tangent. So the two green lines I have, the JM and GL, those lines are perpendicular, so I can draw 90 degrees on either side there if I want to do that. Okay, 10.1, calculate the length of JM correct to 1 decimal place. So JM is the diameter there, so let's look at in triangle JKM. Triangle JKM is a 90 degree triangle there, so we can use theorem of Pythagoras. So angle K is equal to 90 degrees. We said earlier your reason there is angle in a semicircle. So let's use the theorem of Pythagoras in that green triangle. So JM squared will equal to JK squared plus KM squared. That's your theorem of Pythagoras. So JM squared will equal to 20 squared plus 7 squared. Those are the values given there for JK and KM. So JM squared is equal to 449. JM will be the square root of 449, which is 21,2 units. So JM there equals 21,2 units. 10.2.1, if JM is to NM is 2 is to 5, calculate JP. So JN is to NM is 2 is to 5. Calculate JP. So we can say that JN over JM will equal to JP over JK. And that is because line parallel to one side of triangle. We're looking here at triangle JKM. So if we fill in our values that we have for the ratios, we can see that JN is 2 as given above. JM now will be 2 plus 5, JN plus NM. 2 plus 5 is 7. So JM will be 7 there. That's equal to JP, which we need to solve for, all over. JK was given to us as 20. So cross multiply there and you'll end up with JP is equal to 20 times 2 over 7. JP will then equal to 5,7 units. 10.2.2, prove that triangle JPN is similar to triangle JML. Okay, so triangle JPN there is my purple triangle, and triangle JML there is my blue triangle. We need to prove that those two triangles are similar. So we can say angle JML is equal to 90 degrees. That's because the diameter is perpendicular to the tangent, as we said before. angle JPN is equal to angle JKM, that's equal to 90 degrees. That is because of corresponding angles, with PN being parallel to KM. We did mention that earlier. It's in use now, as you can see. So in triangle JPN and triangle JLM, you can say that angle JPN is equal to angle JML is equal to 90 degrees, proved above. Then we can say that angle J is equal to angle J common. Then the remaining angles, angle JNP and angle JLM, will be equal. That's remaining angles of a triangle. That implies that triangle JPN is similar to triangle JML. And your reason there is angle, angle, angle. Okay, 10.2.3. Calculate the length of JL. So we start by saying JN is equal to 2 over 7 times JM. So we did work out JM before. So 2 over 7 times the length of JM will be 6,06 units there for JN. Okay, so from similarity, we proved similarity before in triangle JPN and triangle JML. So from that similarity, we are going to get our ratios here. So we'll say that JL over JM is equal to JN over JP. And we substitute all the measurements that we know now. So JL over JM, we worked out earlier, was 21,2, is equal to JN, we worked out above, is 6,06, over JP. JP, we worked out earlier, was 5,7. Cross multiply there, and you'll get JL is equal to 21,2 times 6,06, all over 5,7. JL is equal to 22,54 units then on the calculator. 10.2.4, calculate the length of the radius passing through circle JLM. Okay, so we say that JL is the diameter, as angle JML is equal to 90 degrees. We proved that earlier. So the radius then will be half of JL. So JL we worked out to be 22,54 units there in 10.2.3. So the radius then will be half of 22,54, which is 11,27 units.